In this video, I'm going to discuss absolute value equations. Well, what is an absolute value equation? Well, an absolute value equation is going to be any equation, so we've got this expression equal to this expression, so it's an equation, but it's an equation that contains an absolute value expression. So we've got this absolute value of x plus 3 equals 5, so we're going to solve that. But before we can move that way, what is absolute value? Well, a good working definition for absolute value is the distance a number is from 0 on the number line. So for instance, 4 is 4 units away from 0, so the absolute value of 4 is 4. Likewise, the distance negative 4 is from 0 on the number line is also 4 units, because negative 4 is 4 away from 0. So we can say that absolute value is always going to be non-negative because it's going to measure a distance. Well, why do I say non-negative? Well, because you have to include the number 0 when you're talking about absolute value, and 0 is neither positive nor negative, but the absolute value of 0 is 0, so we need to include that, so we say that all absolute values are non-negative. So let's talk about our first example. We know that whatever is in this absolute value expression, it's going to be 5 when you take the absolute value, which means it could be 5 or negative 5, right? Because when you take the absolute value of 5, you get 5. And when you take the absolute value of negative 5, you get 5. So when we're working these equations, we're going to notice there's two cases that we need to worry about. We need to worry about the positive case and the negative case. Or sometimes we'll actually have 0 over here, so we'll solve that another time. But anyway, so I'm going to take my absolute value business. I'm going to say x plus 3 equals 5, just like I have written. Or I'm going to say x plus 3 equals negative 5, because the absolute value of this negative 5 would also be 5, as I've said. So we're going to solve these two equations independently from one another. So I'm going to subtract 3 from both sides. My 3's cancel. And x is going to be 5 minus 3, which is 2. On the right side, I'm going to subtract 3 from both sides here, and my 3's cancel. And my x is going to be negative 5 minus 3, which is negative 8. So my values of x are actually 2 and negative 8, and this is the way I'm going to write them with a comma between them to separate them. And let's go ahead and take each one of these answers and plug it back into the original equation and make sure it's okay. So when I have a 2 plus 3 is 5. Absolute value of 5 is 5. Yep, so that one's okay. A negative 8, so negative 8 plus 3 is a negative 5. And the absolute value of negative 5 is 5. So that guy's good too. So in the first example, we had the absolute value of x plus 3, and that equals 5. And our solutions were x equals 2 and negative 8. In our next example, we have a negative 3 times this absolute value expression, 2y plus 3, and that's going to equal negative 9. So in order to solve these things, we have to take this absolute value expression that's here, and we need to isolate this guy. So we need to pretend he's a variable, and we're going to isolate him, and then once he's isolated, we can do like we did in the previous example, when he's all by himself, then we can set up our two separate equations. So let's see how to do this. Well, right now the only other thing on this side is this negative 3 right here. So let's take it and divide both sides by negative 3. So when I do that, the negative 3's cancel, and I have 2y plus 3 in my absolute value bars. And that equals negative 9 divided by negative 3, which is positive 3. And now that my absolute value business is indeed isolated, it's all by itself on one side of the equation, I can go ahead and create two separate equations. So I have 2y plus 3 equals 3, and I have 2y plus 3 equals negative 3. Again, taking into consideration my absolute value business that it can be a positive or negative when it turns into this positive 3. So I'm going to subtract 3 from both sides, and notice my properties of equality, they're going to be the exact same thing for both equations. So 2y equals, and this 3 minus 3 is actually going to be 0. And this 2y will be negative 3 and negative 3 will be a negative 6. So let's divide everything by 2 to get rid of this coefficient of y here. So it looks like y is going to be 0 in that left case. And on the right case, it looks like y is going to be negative 3. So we can say y equals 0, comma, negative 3. And let's plug those values in and see if it works out. So 0 and negative 3 were our values. So 0, 2 times 0 is 0. 0 plus 3 is 3. Absolute value of 3 is 3, times negative 3 is indeed negative 9. So that worked okay. Our other solution was negative 3. So 2 times negative 3 is negative 6, plus 3 is negative 3. But then the absolute value of negative 3 is a positive 3 times negative 3 is indeed our negative 9 also. So it looks like both of these solutions worked out. So the solution is y equals 0 and negative 3. In this example, I have 2 times my absolute value expression here, m plus 4, and then plus 5 equals 1. So as I've done in the past examples, I'm going to isolate this absolute value business. And by doing that, I can just use my properties of equality, subtract this 5 from both sides, and I get 2 times the absolute value of m plus 4 equals negative 4. Then I notice I've got this 2 out here, so I'm going to divide both sides by 2. So they cancel over here. And now I get m plus 4 equals negative 2. Well, at this point you might think, well gosh, let's make our 2 equations and solve this bad boy. But we have a problem. Because this absolute value business right here, m plus 4, is always going to be non-negative, right? Because it's inside an absolute value. But it looks like it says it's equal to negative 2. So how can something inside an absolute value be equal to a negative number? Well, the answer is it can't. So what does this mean for this problem? Well, the answer is going to be no solution, because there is not a value we can put in for m that will ever make this equation work, because recall the absolute value of my expression will always be non-negative, but this is negative, so no dice on that one. So the answer is no solution. In my next example, I have 7 times my absolute value expression, 10w minus 2. Then I'm going to subtract 9, I'm saying that's equal to 5. So like we've been doing all along, I'm going to isolate this absolute value expression by using the properties of equality. And I can add 9 first and get rid of that guy. So I have 7 times the absolute value of 10w minus 2. And that's going to equal 5 plus 9, which is 14. And I can then divide both sides by 7. My 7's there cancel. So I have the absolute value of 10w minus 2 equals, and 14 divided by 7 will be 2. Okay, everything looks okay so far, so let's break it up into 2 separate equations. So I can say my 10w minus 2 equals 2, and I can say my 10w minus 2 equals negative 2. Using my properties of equality, I can add 2 to everything here on both sides of both equations. So these 2's cancel, these 2's cancel, and it looks like actually those 2's cancel as well. So I'm left with 10w equals 4, and also 10w equals, well, those canceled out, so really just 0, isn't it? So when I divide everything by 10, both sides of both equations, 10's cancel, and I get w equals 4/10, which really when I reduce that can be 2/5. And this w equals 0 over 10, which is just 0. So my values for w are 0 and 2/5. And that'll be my solution for that problem. In this next example, we have 3 times this absolute value business and then equals 12. So the first thing that we need to do, which we took for granted a little bit in the previous examples, is that we have to first isolate this absolute value business. So we got to get that stuff by itself, which means in order to do that, I have to divide both sides by 3. Those 3's cancel, and I have the absolute value of 2d minus 3 equals 12 divided by 3, which is 4. Now that I have my absolute value expression here isolated, and it's all by itself, now I can write my 2 separate equations. I can write 2d minus 3 equals 4, and 2d minus 3 equals negative 4. And as we saw in the previous example, in order to solve these, we'll use the same exact properties of equality on both sides. So we'll add 3 to both sides here, and we'll get 2d equals 7. And over here we'll get 2d equals negative 1, because negative 4 plus 3 is negative 1. And to finish it off, we're going to divide both sides by 2 to get that coefficient away from our d. So we get d equals 7 halves, d equals negative 1 half. So we can write it all together now and say d equals negative 1 half or 7 halves. And that will be our solution for that example. In this next example, we have 4 times this absolute value expression r plus 3. Then we have minus 3 equals 9. So in order to solve this, remember, we need to isolate first this absolute value expression. So we can do that by using the properties of equality, like we've been doing to solve equations. I can get rid of these 3's first. So I have 4 times the absolute value of r plus 3 equals, and then 12, because 9 plus 3 will be our 12. And then, like we did in a previous example, we can divide both sides by 4, and that'll get rid of that business. So I get my r plus 3 over here, and it equals 3. Okay, so now, as we've been doing, I'm going to split it up into 2 separate equations. R plus 3 equals 3, and r plus 3 equals negative 3, because the business in here could be either positive 3 or negative 3 in order to take the absolute value to get my 3. And as we also did in previous examples, we'll use the same properties of equalities on both sides to isolate our variable. These 3's will cancel here and here, and we get r equals 0, or we get r equals negative 6. So we could say r equals 0 comma negative 6, and that'll be our solution for that rascal. So as we did in the previous example, let's go ahead and plug these back in and see if it works. Let's plug 0 in first. So 0 plus 3 is 3. The absolute value of 3 is 3. 4 times 3 is 12, minus 3 is 9. So our 0 works out okay. And negative 6 was our next one. So negative 6 plus 3 is a negative 3. But then the absolute value of that becomes positive 3. And 4 times 3 is 12, minus 3 is 9. So I can see that, yep, both of those guys work, and my answer is 0 and negative 6.